All right, here we go. So we have direct and inverse variation. So direct variation, I know we took notes today, but here's a couple things as a reminder. It's y equal kx, where that k is the constant of variation. And remember, for direct, it's going to be the same as slope. And it's always going to go through the origin. And another one is it's always going to be a straight line. So graph is a straight line. All right, so that's stuff that we talked about today. Indirect, or not indirect, inverse, sorry. Inverse. This is the second time me doing this because something messed up on the sound on the last one. All right, so here's direct. Now we've got inverse. So inverse, y, so for direct is y equals kx. For inverse, it's y equals k over x. Okay, so it never goes through the origin. Also, its graph is a hyperbole. Hyperbole. This is what a hyperbole looks like. First of all, you're never going to be asked to straight up graph it, but you do need to be able to recognize it. So it looks like this and like this. So it does opposite quadrants, and then it gets really close to the origin, but never intersects it. Okay? All right, from a table, we did something with the direct. Remember, direct always has to go through 0, 0. But you can't necessarily just immediately say, no, it's not direct. It didn't go through 0, 0. You have to do the test. So I always, so for direct, if you look up here, direct, you divide y over x, right? Because that's how you find slope. Inverse, you're going to multiply y and x. So I always like to start off by starting off by dividing. So if I go over here, remember, I'm going to see if it's y over x first. So 9 divided by negative 3 is negative 3. Negative 9 divided by 3 is negative 3. Negative 27 divided by 9 is negative 3. And sure enough, negative 45 over 15 is negative 3. Since these are all negative 3, and since I used division, I used y over x, this is a direct variation. Remember, think direct division, okay? And my k, my constant of variation, is negative 3. Now, the reason is because you could actually put 0, 0 here, right? Add 9, minus 3, plus 3, plus 3. So that actually could go into the table. And if you put in your equation, which would be y equals negative 3x, if you put that into your y equals and check your table, sure enough, 0, 0 will be there. Over here, we're going to start off by trying to use division. So negative 1 over negative 5 is 1/5. Negative 5 over negative 1 is a positive 5. So you can tell really quickly those are not the same numbers. So it's not direct. Okay, now I'm going to go through and see if it's an inverse, which means I multiply y and x. So this would be negative 1 times negative 5 is a positive 5. Negative 5 times negative 1 is a positive 5. 5 times 1 is 5. 1 times 5 is 5. And 1/2 times 10 is 5. These are all the same. Therefore, and I multiplied. So since I multiplied, this is an inverse variation. My k is 5, and that would make my equation y equals k over x, so 5 over x. All right, so graphing a direct variation. I'm just going to throw an example at you of how they might ask you. All right, I don't know, 2, 3, 4, I don't know. All right, graph the equation if y varies directly with x and y equals 12 and x equals, and x equals -3. All right, so the first thing you need to do is you should see direct variation. If it's direct variation, you should write y equals kx. Okay, my next piece of information is that they gave me y equals 12, so I'm going to go ahead and plug in 12, and x is -3, so -3k. Now I need to solve for k by dividing both sides by -3. So k equals -4. That is not my equation. I have to take, excuse me, take k and plug it in here. So now I've got y equals -4x. This is my equation. So now I can graph it using y equals mx plus b. Remember, the first point that you should think of for a direct variation is the origin. So you should put your origin there. Remember, you could always say plus 0, y equals mx plus b. So this is -4 over 1. I drop 4, right 1. Up 4, left 1. Connect your dots. Okay? All right, this one. So writing an equation and solving. Let's do this one. Okay. If y varies inversely to x and y equals -7 when x equals 3, find y when x equals -3. Okay, so I go through and I see that it's inversely. So if I have an inverse equation, it's y equals k over x. Okay, so now I plug in my information. Y is -7, x is 3, and now I need to solve for k. That's k divided by 3. The opposite of division is multiplication. So k equals -21. That's just my k. That's not my equation. So I have to go back and put k in right there. So this is now y equals -21 over x. That's my equation. Now what it asked me for was what is y when x is -3? So what is y when x is -3? So I just plug in y equals -21 over -3. 2 negatives is a positive. 21 divided by 3 is 7. All right, good old word problems. All right, so the time it takes you to get to campus varies inversely as your driving speed. Okay. If you're averaging 20 miles per hour in bad traffic and it takes you at 1.5 hours to get to campus, how long would it take you or take the trip averaging 50 miles per hour? Now you have to remember y always varies inversely with x. So with that being said, the first piece of information is going to be my y. So my y is equal to miles per hour, making my x equal just hours. Okay, so inversely, I write my inverse equation, y equals k over x. And so they gave me that 20 miles per hour, so I'm going to plug in 20. And it takes you an hour and a half. That's my x. So I need to find my k. That's k divided by 1.5, so I multiply by 1.5, giving me k equals 30. Okay, that's not my equation. That's just my k. So I put that k up here. So my equation let's go over here, is y equals 30 over x. That's the equation. Okay, so now they ask us, okay, so how long would it take for 50 miles per hour? Miles per hour, remember, is y. So miles per hour, I'm going to put 50 here. And then this time I have to solve for x. Now this is a little sneaky because remember, you can't just start by multiplying by 30. You always have to multiply by the denominator. So I need to get rid of the denominator first by multiplying both sides by x. 50 times x is 50x. And then I divide both sides by 50. So x is equal to 3/5, but that's not time. Fractions aren't time. So this I actually need to break down to be a decimal. 0.6 hours. And that's okay, right? Because in the original, they gave us 1.5 hours as 1.5. So 0.6 hours. All right. Hooke's law for an elastic spring states that the distance of a spring varies directly. So this is going to be a direct force applied. If the force of 160 newtons stretches 5 centimeters, how much will a force of 368 newtons stretch from the same spring? All right, so y varies directly with x. So the first piece of information they gave me were newtons. So y equals newtons. X equals centimeters. So now varies directly, y equals kx. And I'm going to plug in my information. So the first is 160, 5, k. Divide both sides by 5, and you get k equals, I think it was 132, or 32. Geez, I can't talk. 160 divided by 5 is 32. Okay, now I take that k, plug it in here. So my equation is y equals 32x. Okay, so now they want to know how many 368 newtons. So newtons was y, so I plug in 368 for y. Divide both sides by 32. And x equals 11.5. So that would be 11.5 centimeters. Final answer. All right, so here are your practice problems. The first 4, you're just telling me if they're inverse or direct and why. And go ahead and give me the direct variation. So, not the direct variation, the constant of variation. Constant of variation. Okay. 3, those are all inverse, or 3 and 4. No, wait, sorry, 5 and 6. 5 and 6 are inverse. 7, 8 are direct, and you are going to graph. You're going to graph the direct variations. And then last but not least, we got 2 word problems for you. Okay? All right, have these ready for tomorrow.